Open the stream to output. Testing. Okay, so it works. Okay, I think that should be it. Yeah.
our neighborhood in the solar system, and then will take us to deep sky objects like the star cluster and the nebulae that are scattered across the night sky. And lastly, the Milky Way and other galaxies. And let's begin. So we'll start close to home first, okay? Let's take a look at the night sky. So you have seen the night sky before. You have seen a lot of stars with just of your eyes. Maybe not so many in Singapore, but for those of you who have been into darker skies, I believe what you know what I'm talking about, the spectacular sights of a very, very starry night sky. It's as if you can just reach out to touch the skies, and it feels so near, yet so far. It's the whole sky is like, I like to say that it's peppered with sesame like the top of a burger. Okay, and it feels like this, but a lot more spectacular. Yeah. So, and every night when you are out there under the dark sky observing things, you will have a different feeling, as if a different lesson you can take away to appreciate when you're appreciating the beauty of the night sky. And there are different ways that you can actually capture it. So what you're seeing here in this image right now, okay, this is known as star trails. Okay, what happens is in this picture is you leave the camera on and then you expose it for a couple of hours, and over time you will actually be able to observe the rotation of the skies of the stars, and as well as the night sky, because the stars will be rotating around, moving along the sky because of the Earth's rotation, and they will be leaving a trail of light that you're seeing right here. So that will be a star trail, okay? And also, sometimes when you're lucky in the night sky, you get to see some fireworks from space, like meteors. So a couple of weeks ago, I was just observing the Perseids meteor shower, and I was very pleased because despite light pollution, I could actually see about 20 meteors in a single night. And here's one that was particularly bright, and you can see that it leaves a very, very long trail of light. And it's actually changing colors because of its chemical compositions. So those will be meteors. Most of them aren't that bright, but sometimes here and there you get to see a very, very bright one. In fact, you might even get to see a fireball just straight across the sky. Okay, now let's move on a little further beyond our night sky. Okay, let's talk about the moon. Right, the moon is the closest cosmic companion. In fact, we can see them as a little brother or something like that of ours. Okay, as you can see here, its average distance is 384,400 kilometers away on average, okay, with a diameter of 1,737 kilometers, and that is about a quarter of the Earth. And it might seem a little incredible, but actually, without the moon, complex life on Earth like us may never have existed. Because the moon plays an important role in terms of stabilizing the Earth's rotation. And without it, the Earth will be spinning around like a wild top and wobbling, and therefore we will be unable on Earth to support a stable climate that could lead to the formation of complex life. And also, because of the moon's tides, it helps to create environments that are suitable on land for life to emerge. So two of the most important objects in the universe that are to the creation of life on Earth. Number one is the sun, and number two will be the moon, without either of which complex life like us would never have existed. And it seems by pure cosmic coincidence that we just live in an era when, you know, the size of the moon and the size of the sun in the sky, okay, the apparent size, okay, I'm not talking about the absolute size, the apparent size are almost exactly equal. And that gives us total eclipses, total solar eclipses. And that's when the moon moves in between the Earth and the sun, and the moon will block out a lot of light, most of the light from the sun, and leave us with a very, very spectacular corona that you see around here, around the moon, around the sun, okay? And it's very difficult to emphasize what coincidence it really is, because every single year, okay, the Earth is moving away from the Earth bit by bit, okay? And at some point, it's gonna be so far away, so far out, that total eclipses never become possible again, because the moon will appear smaller and smaller and smaller, while the sun will appear to remain around the same size. So if you can imagine, it actually takes, after a while, the moon will be too small to ever cover the sun's disk fully again. But right now we're in this era when this actually happens, and it happens every couple of years, which is in cosmic sense quite frequently. So just think about it and how lucky we are to be able to enjoy such sights. And sometimes when, because the moon's orbit is not exactly circular, it's slightly ovalish, so sometimes it'll be a little further and sometimes it will be a little closer. So because of varying distance, when an eclipse happens when the moon is slightly further away from the Earth, and it passes between the Earth and the Sun, then we get an annular solar eclipse. And that's when you get this ring of fire that you see right here. So this picture was taken in 2019 annular eclipse in Singapore. And yeah, that's really you can really see, I'm sure those of you who observed it that day itself can really see the ring of fire in the sky. All right, yes. Sometimes the opposite happens. Instead of Earth coming between the Earth and the Sun, instead of the moon coming between the Earth and the Sun, the Earth comes between the moon and Sun, which means, in other words, well, the moon slips into the Earth's shadow from the light source of the Sun. So that happens, when that happens, we actually get a total lunar eclipse. Okay, so when it's exactly lined up, you'll see that the moon is actually slipping inside the Earth's shadow, and it will start to take on such a very, very red, deep red color. And that's why we call it the blood moon. It's a common nickname given to lunar eclipses called blood moon, because it's really reddish in color. And that red color forms because of the refraction of light that's passing through the Earth's atmosphere and going to the moon and then bouncing back to us. So the Earth's atmosphere will actually scatter away the blue light, leaving the red light behind to reach the moon and reflect it back to us. And when we observe it, that will be a blood moon, so-called. So this picture was taken just a couple of months ago in in late May, during the most recent total lunar eclipse. And actually in the background, the stars that you're seeing are the stars of Scorpius. Yeah, so this picture was taken then as well. It was taken in Taiwan. And yeah, you can see the moon actually rising slowly above the horizon, over the clouds into the sky. And when I was there observing it myself, I think it's really a sight to be remembered, because of the color and the gradients of the lights coming across the moon. And then when you imagine, this is what happens when the moon is actually going into the Earth's shadow from the sun's light coming from 150 million kilometers away. I think the perspective and the scale of what you're witnessing, I think it is quite a breathtaking experience. And so let's go a bit further to two planets that are quite close to us, okay? Mercury and Venus. So these two planets are actually not easy to observe because they are always so close to the sun. They either appear during sunrise or during sunset. And yeah, especially Mercury, because it's so close, it orbits the sun so closely that it's always near the sun and it's not that bright itself. So it can be quite difficult to observe. But of course, on a very, very clear day, and Mercury is at the furthest point from the sun, is completely possible. Whereas for Venus, it is always on the same side of the sky as the sun, but it can appear much, much brighter due to its high reflectivity and close distance. So here what you see is a conjunction with Venus, okay, on at the upper left, and the moon on the lower right. Okay, so on a clear evening or clear morning, based on where Venus is, you can actually observe Venus in the sky as a very, very almost glaringly bright point of light in the sky. I still remember the first time when I saw Venus myself, and I was just brushing my teeth and I was looking out the window and suddenly realized, wow, what is that? It's incredibly bright. And when I went back to check, oh, that was Venus. And yeah, sure, it really took me aback, and that was the first time I realized how incredible that looked. So this was taken in Singapore a couple of years ago. As you can probably tell, it's taken in HDB estate. And so when you're looking through a telescope, right, and at Venus, you can actually see that it exhibits a very queer property, that it shows phases, like what you see here. Okay, this is a series of images compiled by NASA, but it really kind of resembles what you can see through a telescope when Venus is in the right position. So the interesting thing is that Venus exhibits phases just like the moon. You have gibbous phase, you have quarter phase, and you have crescent phase. That's the reason for that is because we are observing Venus from a side angle, okay, because it's closer to us than the sun, so it will never be directly behind us. So it will always be illuminated from the side. And that is when it will form the phases that you see right here. And yes, it's not that hard to observe at all. Through our telescopes, if Venus is up, you can feel free to look through it and you might be able to observe just this. And then let's get and go to the red planet, Mars. So Mars actually, because of this close distance to Earth, it only swings by and comes in opposition, which means that it is on the other side of the sun from the perspective of the Earth, and that's the closest point at which it is to Earth. So that only happens about once in every 2 years because of its close distance to us. So when that happens, other than the very, very bright point of light that is distinctively reddish in the sky with naked eye, if you look through a telescope, you can actually see some surface features on it. And I think what's the easiest to observe and the most enchanting part of it is really not just the deep reddish hue, but also the polar ice caps that are frequently observable. So Mars actually shares a similar tilt to the Earth, which means it has seasons. And during the seasons, okay, you actually have carbon dioxide in Mars' atmosphere forming to become dry ice at the north and southern polar ice caps. Okay, so you'll see a layer of white at the poles of Mars. And I think that's really an amazing thing to witness with your own eyes. And of course, if you have the right equipment, you can also take an image like this that shows some surface features of Mars as well as the polar ice caps yourself. And this, of course, is taken by NASA, not any regular equipment. This is taken by a space probe sent to Mars. And here you can actually see very distinctive terrains on Mars. Right here is Valles Marineris, okay, one of the largest and longest canyons in the solar system. And at the side here, you actually have volcanoes that are on Mars. And moving on, we then have Jupiter. Jupiter is, as many of you know, it is the largest planet of the solar system. It is so large, in fact, that you can put all the other planets together, of course, including Earth, Mercury, Venus, Saturn, Neptune, Uranus, all of them put together, and Jupiter would still be 2.5 times larger, 2.5 times more massive than all these planets combined. So that is the true huge, massive scale of Jupiter. Okay, and yes, and its gravity is so strong that it can actually help to deflect asteroids that are coming into the solar system, into the inner solar system, and might hit Earth. So that's why some people actually call it the janitor or the sweeper of the solar system. So this is taken by NASA's Juno space probe. It's a recent space probe that was sent to Jupiter in 2018, if I remember correctly. So this planet would, I mean, from this image you can really see from a different perspective, close up to Jupiter, the really intricate patterns and storms, the top patterns and storms that are on Jupiter. You see all these swirling patterns, all these belts. All of these are cloud formations of Jupiter, and they have a slightly different color because of the chemical composition of the atmosphere in that particular region. And upper right here, you can actually have the Great Red Spots, right? The Great Red Spot is one of the largest storms in the solar system and has been there for at least 400 years, blowing continuously, right? So through a telescope like some of what we have at NUS Astro, you can actually see very clearly the Great Red Spot when it appears. Sorry. And I think this is a big crowd teaser. A lot of people often get really, really amazed by what you see. And that's Saturn, okay? Saturn has the most distinctive ring in the entire solar system of all planets, okay? And honestly, they are not that hard to observe. Through one of our telescopes as well, just look at it and you will actually be able to see its rings quite prominently displayed. Okay, it's really not that hard. It will just appear like what you see in textbooks, on online websites and so on, and you will have yourself wow. Okay, really. And on a good night, you can even see this this gap here. This gap in Saturn's ring is called the Ophiuchi division. So this picture was taken by NASA's Cassini spacecraft, which was decommissioned in 2017. It was the only Saturn orbiter that was sent out there so far. Okay, and from the data that was collected through its observations, scientists currently estimate that in the solar system estimated 9 billion year lifespan, that's a long time, okay? Saturn's rings exist for just a mere 100 million years, or even shorter. So to get a sense of what it's like, imagine someone living to 90 years old, and then you only get this for like 1 year of that person's life. So you can kind of get an idea of how short the span of these rings is. Okay, so it is estimated that after 100 million years, the rings will begin to thin out and slowly disappear. So just think about how lucky we are again to be able to be alive in such a narrow gap in the solar system lifespan that actually allows us to observe these spectacular rings of Saturn. Okay, and see the last two planets we covered, Jupiter and Saturn, right? Once in every about 20 years or so, they will come very, very close together. Okay, and last year in December, and if some of you remember, there was this great conjunction. Okay, so this great conjunction was when Jupiter and Saturn appeared to come very, very close together in the night sky and become almost like twin stars, binary stars of sorts. And when you look through a telescope, you can actually see both of those planets and the surface features together in the same view. It's a lot like what you see in this image right here. So this happens on average about every 20 years, but usually it doesn't get this close. 2020 was special because this was the closest they had been since the 17th century and will be the closest they will be until 2080. All right. Yeah. So that was really you can say this was a once in a lifetime event to witness. Moving further beyond Jupiter and Saturn, we have the ice giants. Okay, these planets are very, very, very far out. And for the most part, they lie beyond naked eye observations, certainly in Singapore. Okay, some said that you can actually see Uranus at the edge of naked eye observation limits in very, very dark skies. All right, but even in Singapore, right, if you have a telescope, you can actually carefully observe these planets, and you can actually still see their light blue as well as your hues. And now let's move beyond the planets and go into the universe. That's when we go first to star clusters. So star clusters are a very, very interesting and frankly quite amazing object because of their shape and the density of stars that they hold, right? So what you see here is called Omega Centauri. It is one of the largest star clusters in the universe. It is a group of stars that's held together very strongly by the mutual gravity. Okay, so to us, it will appear as if like a globe of stars that's hanging there in the night sky. And this Omega Centauri, it's so large that astronomers speculate that it could once have been a single galaxy of its own. That was eventually it was cannibalized by the Milky Way. It merged with us, and the Milky Way's greater gravity stripped away most of its outer stars, and the inner stars remained and became one Omega Centauri, which is therefore that could be why it is the largest star cluster, globular cluster in the Milky Way. So it is estimated that if you were in a star right in the middle here, if you were orbiting on a planet orbiting a star inside here, the nearest star to you will only be 0.1 light years away, which is 1 of 40 to the distance of our nearest star, Alpha Centauri, that we can observe right now on Earth. So that really gives you a kind of idea how densely packed the stars in here are. And then in contrast to globular clusters, there are also open clusters. So globular clusters, like I said just now, they appear as if to be a ball of stars hanging in the sky, all right, in the universe. But open clusters are different. They are much more spread out, and they take on very, very different shapes all the time because of their more spread out nature. So these open clusters tend to be younger because they might have recently just formed from nebulae and so on, right? So here, what you see here is a Pleiades star cluster. Okay, it's also known as Messier 45, as some of you might know. It is the brightest and most well-known star cluster in the night sky. Okay, it's called the Seven Sisters because in the past, when ancient people were observing this particular star cluster, they thought they could see 7 stars within the star cluster. So they called it the Seven Sisters. Okay, but nowadays, through our advanced observation techniques, we have realized that there's way more than 7 stars in here. There are hundreds or even thousands of stars right here, of which, of course, some of those are more prominent. So one of the more mesmerizing things about this particular nebula is between this, about this star cluster is between the star cluster and Earth, there actually lies a patch of floating dust in universe. Okay, just in between. It has nothing to do with Earth, or it's nothing to do with the cluster itself, but it's just sitting there. Okay, so that when we observe this particular star cluster and expose it in the camera for long periods, you can actually see a lot of these patterns that are being illuminated by the stars as the light passes through the nebula and to Earth. Okay, so that's what you're looking at here. And yes, the Seven Sisters is so bright that it can be seen from Singapore, even under heavy light pollution. Even under the heavy light pollution, or let's say Singapore CBD, you can actually see a very, very faint patch in the sky. And I think that's quite amazing of how really bright it is. Okay, moving on, where we have nebulae. Okay, nebulae are also called stellar nurseries. Okay, what they are clouds of gas that are floating around in space. Okay, and the reason that they're red is that they're mostly composed of hydrogen. And when hydrogen is being ionized, it actually gives out a very, very specific wavelength of light that we commonly known as hydrogen alpha. Okay, that appears red to us. So that's why in the most nebulae that you see are actually deep red in color. Most. Okay, and when these nebulae collapse, okay, they actually form stars. So when the gases collapse, they become more and more packed together, and eventually gravity will be strong enough and pressure will be high enough to ignite nuclear fusion at the heart of these clouds, and soon they will form stars. So many a times when you see star clusters, right, they are actually collapsed nebulae that forms stars. Okay, a whole cloud collapses, and then inside this cloud you form lots of little stars out there. Sorry, not little actually. They're pretty great. They're pretty huge. All right, so you form lots of stars, and they become star clusters, and that's why these nebulae are also called stellar nurseries, because within them often you have a lot of star forming activities. So here is one object that I really like to share with you. This was taken by NASA's Hubble Space Telescope. It's one of the Hall of Fame images by the Hubble Space Telescope. It's called the Pillars of Creation, and it lies in the Eagle Nebula. Okay, and what you see here are actually called dark nebulae. They are not hydrogen; they are dust floating in space that absorb light all around them, and that's why they appear to be dark. Okay, dark patches. And it happens that they are arranged in such a manner that it looks like pillars, okay? And that's why it's called the Pillars of Creation. And you can actually see near the tips as well of the nebulae, that you can actually see rays coming out of it. So what's happening within these pillars is that stars are actually actively being formed. So when these stars form, they're young, they're energetic. So they start blowing out energy at a very, very rapid rate. And they start blowing out these dust that surround them, blowing away, and that's why you can see as if they're pouring out energy of some sorts. Okay, so that is one of the features of the Pillars of Creation. In fact, with amateur equipment, let's say just a telescope and a camera, you can actually take a picture of the Eagle Nebula, and within it you will be able to see these Pillars of Creation yourself. They're not that hard to observe. Okay, and now one of my absolute favorite objects. It's called the Ophiuchi Complex. I know it sounds complicated, but you know, it lies in this constellation called Ophiuchus, and it happens that it is at the intersection of the constellations of Ophiuchus as well as Scorpius. Okay, so right here inside you see this largest, brightest yellow star, red star actually, right here. This is star Antares, which is the brightest star of Scorpius. Okay, and perhaps the most interesting thing about this particular object is look at the colors that it exhibits. Some people say it almost looks like infinity stones or something like that. You see the red here. Remember when I told you that nebulae, floating hydrogen emits red lights, right? Hydrogen alpha. So this part is emitting hydrogen alpha. This part near Antares, okay, is actually reflecting the light off and It's just so the light of Antares, and just so happens that Antares is so deep red that the light it reflects is also a strong reddish color. That's why it appears reddish, orangish, sort of. Okay, and then here you have another reflection nebula that is reflecting light of the Rho Ophiuchi here, which is bluish in color, and that's why you have 3 different colors all in the same patch of sky. And also there are a lot of dark nebulae in here, which is dust, like what I said just now, like you saw in the pillars of creation. So these dust will absorb the light, and therefore they appear as dark patches in the night sky. And I think what's really the most amazing is how the perspective it kind of gives you. It feels like it almost gives you a sense of depth, a 3D feeling into the nebula itself. And that's why it's so mesmerizing to look at. And hence one of my absolute favorite objects. And now let's come back to, actually not come back, let's move on to our home, the Milky Way. Okay, the Milky Way is our home galaxy. So all those deep sky objects that you saw previously, all the nebulae, all the star clusters, they are all a part of the Milky Way. Okay, this is, in the cosmic sense, our country. Okay, this is where all of the stars that are near us are concentrated. Okay, and to us, you can actually observe the Milky Way as a line of light that's in the night sky. Okay, for those of you who might have seen the Milky Way before, you will have noticed that it's almost like a whitish arc that stretches across the night sky, across maybe the entire night sky, maybe if the skies are dark enough. Okay, a bit like this. Okay, so what you're looking at here is actually called the summer Milky Way. The core of the Milky Way is at its highest point to us in the summertime. Okay, it peaks around mid-June or so. So that's why some people also call this part the summer Milky Way, the core of the Milky Way. Okay, this is also the brightest and most easily observable part of the galaxy. Okay, and yeah, so for those of you who have not, in future when travel resumes, feel free to join us on one of our Astro Bash trips, and we can go to a dark side together, and hopefully we'll be able to see the Milky Way. Okay, it's called the Milky Way because in ancient times people thought it was like a path that is whitish in color, milky, and yeah, therefore Milky Way, right? Yeah. So in the Milky Way, actually, you can see a lot of these features, dark features, lanes, black, darkish lanes. So all of this, right, are not gaps in the Milky Way star field. What they are is a layer of dust that lies between us and even further out stars that blocks out their light. They're in effect also like dark nebulae, okay? And this dust prevents light from further out from reaching us, and therefore you can see all these very intricate patterns lying around in the Milky Way. So this was taken on Taiwan's Hehuanshan, okay? Up there, the skies are really, really dark. If you ever have a chance to visit, please do, okay? And the Milky Way that you observe there with naked eyes almost really resembles what you see in this picture based on the amount of detail that you can actually see. It's really spectacular, and it's as if this entire line of starlight is popping out at you in 3D manner. And so now we dive a bit into the core of the Milky Way. Okay. Now, first of all, if you can notice, there's a special bright object here. Okay, it kind of looks like a star from this image, but it's not. Okay, because when we dive deeper, you'll realize that it's actually a nebula. This is the core of the Milky Way, and what you see here, the larger object is known as the Lagoon Nebula, and the smaller object is known as the Trifecta Nebula. Okay. Meanwhile, all these dark patches that you see all scattered all around the image, these, like what I said, are not gaps in the star field. Okay, if all of these are dust that are just floating around in space and absorbing the light. If they were not present, you would be able to see the entire star field look like what you see in the lower right corner. Okay, very bright, very white, and yes, but because of the presence of these dust, they kind of give us a very, very special pattern that we can appreciate, and it's almost like a painting. Okay, like what you see here, all of these are dust. Okay, cosmic dust, interstellar dust. And this kind of is a very interesting perspective and gives it sort of a bit of depth to our observations of the Milky Way. Okay, here you can see a cluster, a star cluster here known as the butterfly cluster. And below here, you have another one called the Ptolemy's cluster. And now moving beyond the Milky Way, we have millions and billions of galaxies throughout the entire universe that we can observe. And all of them are of different shapes. You can see all 3 different galaxies here all have different shapes. right? So I have to say that observing, or rather just looking at pictures of galaxies is one of my favorite things to do, because just imagine the scale of these galaxies. Each of them is maybe tens of thousands of light years across. They can hold billions and billions and billions of stars. Our Milky Way alone holds about 200 to 400 billion stars alone. And think of the scale that it is to reach them, about tens of millions of light years out. Okay, and just thinking about these itself, over time you start realizing, it starts getting into you how truly huge our universe is. And we are just one of these galaxies as well, right? Yeah. And so with that, okay, on that note, welcome to astronomy. You are about to embark on a journey that will forever change the way you look at the night sky, okay? You will never be afraid of the dark again, because you will find the darker the night, the more sparkling jewels you can find in the night sky. You'll realize how small and insignificant we are, but at the same time, you also realize how empowering that can actually be, all right? You will behold the beauty that lies beyond our naked eyes, scattered across the vast universe, okay? Yep, and with that, that will be the end of our talk today. Thank you very much for your attention. I hope you enjoyed it and learned something out of it. And please follow NUS Astronomical Society at the following social media pages, and feel free to follow me as well. And with that, let's take a moment before we move on to our next segment, today's Kahoot quiz. Okay, give me a moment. Let me just get it prepared. All right, there we go. So go to kahoot.it and then key in the game pin, and we will get ready in a few minutes time. All right, we'll have we'll give it about a couple of minutes for everyone to join, and then we'll begin.
Yeah. Give me like 5 minutes.
All right, let's give it about 2 more minutes, and then we'll begin. In the meantime, if anyone has any questions about talk just now, feel free to just ask away. All right, 1 more minute. All right, is everyone ready? Shall we begin soon? All right, apparently I have an impersonator up here. All right, let's begin. So about the talk today, let us get ready to begin. How does a blood moon occur? Yes, very good. Most of you got it. The Earth enters between the Moon and the Sun. The other option, the Moon enters between the Sun and the Earth, that would be a total solar eclipse. Okay, and that would be when the Sun is blocked out by the Moon. All right. Well, when the Moon is hit by an asteroid, does it bleed? Well, okay, it doesn't. And yeah, the Moon does not turn red because of iron being ionized. In fact, iron is not so prevalent in the Moon compared to, let's say, on Mars. Okay, let's move on. True or false? False. Okay. Saturn's rings are only around for about 100 million years. It's a very, very short time compared to the entire lifespan of the solar system. Well, okay, let's move on. What is the name of the object that I dubbed cosmic pellet? Very good. The Ophiuchi Complex. That was the picture that we saw just now. Okay, this object, one of the most colorful objects in the night sky. All right, let's move on. Why are Mercury and Venus always seen close to the Sun? Very good. Their orbits lie within that of the Earth. That's why they always appear closer to the Sun as compared to other planets. Okay. Technically, the other option, the Sun's gravity is so strong it pulls the planets towards it. It's not technically wrong from a physics standpoint. I mean, the Sun's gravity is pulling them towards the Sun itself. That's why they are in orbit. But it applies for all planets, and not just Mercury and Venus. Cosmic coincidence? That would be a bit too coincidental. All right, let's move on. So in the Great Conjunction of 2020, which two objects appear to be very, very close to one another? Jupiter and Saturn, very good. Okay, so the picture that you saw just now, actually, this was another conjunction between Venus and the Pleiades star cluster in April of 2020. Okay, but the Great actual great conjunction last year was between Jupiter and Saturn. Let's move on. Which of the following traits do you need to be an amateur astronomer? There's more than one answer. Yes, very well. You need a working pair of eyes, of course, to see the sky, to see the stars, as well as curiosity and an open mind to new knowledge that's beyond what you're usually exposed to. Okay, of course, you don't have no rocket science by heart. Most people don't anyway, and there is no minimum IQ barrier to enjoying the night sky. Anyone can do it. All right, and moving on. What kind of object is this shown below? It's a galaxy, it's a nebula, it's a star cluster, or the cloud in the sky. Very good, it's a nebula. Okay, so what you saw here, this is called the California Nebula. Okay, it's called the California Nebula because its outline, people think that it looks a little like the state of California in the United States. And also it happens that the declination of this particular object corresponds to the latitude of California, as therefore it appears that every year it will pass directly overhead California. Okay, that's why people call it the California Nebula. All right, moving on. So we have a great view of the Milky Way's true shape because we live inside of it. True or false? False. Okay. We don't know how the Milky Way truly looks like because we're inside of it. We can't see its entire appearance. Okay. But we can have some guesses because astronomers are trying to map out the positions of all the stars in the night sky by measuring our distances to them as well as plotting them out into a 3D model. So they concluded that we live in a spiral galaxy and we are in one of the arms about 2/3 away from the center. Okay, moving on. It's impossible to see any deep sky objects from Singapore. True or false? False, definitely false. With the naked eye, one of the most prominent deep sky objects you can see will be the Pleiades star cluster. Okay, so the Pleiades star cluster, yeah, that's one that you can observe with your naked eye. If you have a telescope, more objects will start appearing, such as the Orion Nebula. Okay, even through our telescopes, you can actually see some of the nebulosity of that particular objects, and you can also see a lot of other star clusters with the telescope as well. And now, moving on. The last question. What's the traditional nickname given to the Pleiades star cluster? 7L, 7 sisters, 7 stars, 711. Seven sisters. Oh, 711, 3 of you selected that. Very well. Okay. Now, yeah, so Pleiades star cluster was known as the 7 sisters because in ancient times, people could mostly see 7 stars in the entire star cluster. So they called it 7 sisters. And now, that will be the end of our quiz. Let's see who our top 3 are. Okay, very well. Congratulations to our top 3 and as well as our runners-up. And that will be the end for today. Thank you very much. And we'll see you again when our sessions, at next week's session. Okay, goodbye.